We'll be looking at examples from 1.6. Specifically, we'll be looking at problems like number 1 through 5 from our online XYZ homework. All right. For problem number 1, you will see something to the effect of square root of 0.81. Well, we can simply use our calculator to evaluate this. The question is, what number times itself is 0.81? Well, that's 0.9. Because 0.9 times 0.9, the reason this is, we know 0.9 squared is 0.81. And that is our definition of square root. What number times itself yields this underneath part? This underneath part is called the radicand. This little symbol is called a radical sign or radix. All right, another one like number 1 may look like this. It may ask us for a cube root. Let's say the cube root of 27 a to the 12th. Now we want to know what number times itself 3 times yields 27. Well, that's going to be 3. Okay. But what about a to the 12th? What power of a times itself? 3 times gives a to the 12th. Well, that's a to the 4th. And all you have to do is, whatever this index is, we call this the index of the root, you simply divide that, the power inside by that index. Because when we say the cube root of some value x, we can also write that as this term to the 1 over this power. To say the cube root of x is same as saying x to the 1/3. And we know from our product rule that if we have some example, if we have, say, m to the 12th, and we take that to the 1/3 power, we can simply multiply 1/3 times 12, and that is m to the 4th. So it's the same thing we're saying here. To say a to the 12th, the third power of a to the 12th is the same as saying m to the 12th to the 1/3. All right. Now, one like number 2. Let's say we have 4 to the negative 3 over 2. Well, to begin with, you may remember from our rule of exponents discussion that anything to a negative power, m to the negative a power, I simply write that as I use the reciprocal. It's 1 over m to the positive a. So anytime we have a negative exponent, I'm going to, if we are in the numerator, we'll write it in the denominator, or vice versa. So I will first begin by rewriting this as 1 over 4 to the 3/2. All right. Well, when we have a fractional exponent, the bottom number is the root, the denominator is the root, and the top number is the power. So this 4 to the 3/2 is the same as 1 over 4 cubed and the square root of that. Well, 4 to the 3rd power is 64, so this becomes 1 over the square root of 64, and hopefully you know that the square root of 64 is 8. This is 1/8. All right. Number 3. in number 3, we have some kind of quotient, like x to the negative 1/4 over y to the 1/8. And all this is taken to some power, like 40. Well, remember our power rule for exponents. When we have some number to some power and that is taken to a power, we simply multiply these two. So I'm going to begin by doing that. Negative 1/4 times 40 will be negative 10. Y to the 1/8 times 40 will be y to the 5th. Well, lastly, we have this negative power. We shall move that to the denominator. We have 1 over x to the positive 10, and the y to the 5th will remain where it is. Remember, when we write this in the computer, we'll put it in this fashion: 1 divided by, and we want to group this denominator in parentheses. It will be x to the power of 10, and then y to the power of 5. Close parentheses. Use of parentheses will be important as we enter in these answers. Number 4. Let's say we have 16 x to the 8th, y to the 10th, and this is all to the 1/2 power, divided by y divided by 27 x to the negative 12th, y to the 9th, and this is all to the negative 1/3. Alright, 16 to the 1/2 power, that's the square root of 16, that is 4. X to the 8th to the 1/2 becomes x to the 4th. Eight times 1/2 is 4. Y to the 10th to the 1/2, that's y to the 5th. Divided by 27 to the negative 1/3. Right now it's a power of 1. I'm simply going to write this as 27 to the negative 1/3. We'll discuss what we'll do with that here in a second. X to the negative 12th to the negative 1/3. Negative 12 times negative 1/3 is an x to the 4th. Y to the 9th to the negative 1/3. 9 times negative 1/3 is a negative 3 power. Alright. Well, we've discussed previously, anytime we have a negative exponent, we're going to, if it's in the denominator, move it to the numerator or vice versa. Alright, so this becomes moving this 27 to the negative 1/3 to the numerator. We have 27 to the positive 1/3. I'm going to group this in a parentheses. Still have our 4 up there. Still, we notice here that the x to the 4th and x to the 4th, they will divide each other out. Alright, this y to the negative 3rd, we could move it to the top and it would become y to the positive 3rd, but we'd have y to the 5th times y to the 3rd, that'll be y to the 8th. Alright, and that takes care of all of it. We're just simply left with this 27 to the 1/3. Well, 27 to the 1/3, that is the cube root of 27. What number times itself 3 times yields 27? Well, it's 3. So this factors 3. 3 times 4 is 12. Our final result is 12y to the 8th power. Lastly, like number 5. Let's say we have the square root of 32. Well, this time we cannot evaluate the square root of 32 and get a rational number. We would get an irrational number. So we're going to write this in its simplest form. So what I want to do is write 32 as a product of some number I can take the square root of. 32 is 16 times 2. The square root of 16 is 4. Thus, technically what's happening here is we write this as a product of the square root of 16 times the square root of 2. The square root of 16 I can take the square root of, and that leaves 4, so we're left with 4 square roots of 2. But it's perfectly okay for you to think about going from this step to this step. The square root of 16 is 4. We write it on the outside of our radical. Much like it's a coefficient here, it's 4 times the square root of 2. 4 times the square root of 2 is equal to the square root of 32. And that concludes examples like 1 through 5.